Okay, hello, this is Spencer Thornhill. I'm a student here, and this is the CFAT techniques that I did for my little project. So, yeah, just wanted to go through some of them with everyone here. All right, so first and foremost, we have credential stuffing. So, this is actually a pretty simple technique if you think about it, but it's just an automated cyber attack using stolen username password combinations. So, all it's doing is it's exploiting all of these passwords that people reuse across multiple platforms. I'm one of these people. It's a problem. And if you have these passwords all over different platforms, if they get one, they can take it, that combination, and use it across a bunch of different sites and maybe financial services, stuff like that. So they use tools to just kind of input them everywhere. They'll use things like IP rotation. They'll do browser fingerprint spoofing. They'll do human behavior simulation, some really advanced stuff. This is higher level, but it's something we have to look out for. The prevalence of this is going to be about 50% of publicly disclosed data breaches. I don't know about you, but in my opinion, that is incredible. That's incredibly high to see something like that happen. And it's kind of driven by an increasing data breaches and credential availability on dark web. So basically, people will sell credentials to each other, online, and then they'll just kind of run them through an algorithm that sends them out to various inputs and see what sticks. And once they get in, then they're in. And again, like I mentioned earlier, it's exacerbated by our own habit of using passwords over and over again and again. So here's an example of one. So, financial services and e-commerce platforms are particularly impacted. So your bank, your retirement savings, stuff like that. And the first case I have, there was 250 login account attempts on a single account on Christmas Eve for this one person. What was really interesting about this is that Christmas Eve or any really like holiday, right, with lots of family or gifts or anything like that, there's a lot more online activity. And so what they do is they will take in, they will output all of those passwords they've kind of saved up over time, and they'll just kind of do a mass launch of all of them. They'll deploy all of them to various sites to kind of mask their behavior. So they can't get caught as easily because, as if you've ever been, Cyber Monday shopping, you might get a site that just goes down just because there's so many people shopping. And so they kind of throw in their passwords with the rest of them to kind of not get caught. So it's an interesting tactic that some of these people use. Case 2, there was 5 distinct attacks using same credentials within 3 hours, according to this site. So this was one person, and they were getting attacks on their bank. They were getting attacks on, I think it was like a Roth IRA account or something like that. Just various things, and it was very targeted. And that was the point of this, is that it can be a targeted attack where they use the same credentials very quickly in a short span. All right, so just some prevention and a reference for you if you would like to see it. Implement strict password policies promoting unique, strong passwords. So this should be passwords that aren't easily guessed. This shouldn't be your birthday, your name, your phone number, whatever. It shouldn't be anything like that. It's got to be unique, and it's got to be somewhat challenging to use. I personally use some generated passwords for stuff I don't care about as much. But for, maybe more bank account things, you should probably come up with something complicated that only that kind of thing. Something else we should do, we should reduce the feedback on failed login attempts. So if you'll notice, maybe in the past, there was sites that you'll like log in incorrectly, and they'll say like username was incorrect, or email was incorrect, or password was incorrect. And that kind of singles out to the person like, oh, that's wrong, so I need to figure out what the password is, and that's it, right? But maybe with a bit more, you'll notice some websites are doing more of a like, oh, that was just incorrect credentials, bar none, right? And so you don't get a hint as to, oh, was it the username, was it the password? Oh, I have the password right. I can use that somewhere else, right? And so that's something we have to look out for is just don't give as much feedback on failed login attempts. I know it's somewhat annoying as a user, but I think it's an important thing we have to look out for. All right, and there's just things you can that are pretty unusual for login patterns. Logging in, logging out, very quick succession, things like that. It's like, I keep trying to log in, like in milliseconds, and that's unusual, and that usually gets flagged these days. And then the easiest one is the multi-factor authentication. I'm sure we all have it now. Even Okta for UNLV has it now, but using multi-factor authentication is a strong step in the right direction. I will say there are some videos out there, they're kind of more cutting edge about how multi-factor authentication itself can be hacked. It has to be a little more targeted, but it's basically based on the phone lines. It's not even really like preventable. Now that's a future risk we have to kind of look at. But as of right now, the general user is not going to be targeted generally, right? And so multi-factor authentication kind of cloaks that. And basically what we're doing right now, talking about technological solutions, doing policy changes in corporations, in organizations, in government, and then educating all the users on what's best practice. And if you like the report or the reference itself, is from F5 Labs. You can kind of click this link in the PowerPoint that I'll provide in my post on Canvas. All right, moving on to cryptojacking. Here's just a quick explanation. So unauthorized use of cloud computing resources for cryptocurrency mining, which I'd argue is one of the worst things ever because it's extremely expensive to mine for cryptocurrency. If you haven't already heard of all the fads around that. It exploits the credentials to access legitimate cloud users. It hacks in, and it involves privilege escalation and subscription hijacking. So basically what's happening is it will get into your subscription or your privileges on your cloud base, so Azure or AWS, something like that. And then it'll install a crypto mine software on a newly created virtual machine and try to hide it from the user themselves. So basically it's like they get into your cloud, they install a crypto mine, and they hide it and let it run, and then they get all the profit from it. Here's some prevalence. I didn't get exact statistics based on the Microsoft report that I read, but it's significant and it's growing, and you can imagine it's growing. There's a huge financial impact though. So there's over $300,000 in compute fees observed in some attacks, and if you know cloud computing at all, you'll know that $300,000 is actually pretty difficult for like a single user to run up. I mean, of course, companies can do so, but that's a pretty big impact for a single user if they get hacked. And it's a really widespread issue across a lot of cloud environments. So here's an example. So the deployment of an NVIDIA, I think I'm saying that right, NVIDIA compute cores using virtual machine scale sets, and it was a predictable attack pattern across a bunch of different subscriptions. And so they got a bunch of different cores and did a rapid approach using a lot of automation and very efficient algorithms. And they would move the resources to different users to hide their activities. So again, they would get as much cores as they can using NVIDIA GPUs on virtual machines in the cloud. They would get as many cores as they possibly could, and they'll kind of take a bunch of hijacked subscriptions that they get. They'll do a quick automation of it, and then they'll run it all to different users to hide their activities. So it's extremely quick and dangerous, and then you might not even know it's happening until your bill is very high. So here's some really good prevention opportunities for us. You can separate the privilege roles, admin versus normal user accounts. That's just really important, right? That's just best practice in general, but your admin should have only the admin should have access to creating those kind of virtual machines, all that cloud access that could possibly delineate all these cores and stuff across virtual machines. So those need to be very protected. And then privilege identity management for non-admin users. Of course, we're going through this in our course right now. This is just basics to the protocol. Again, similar to the last one, MFA is very important for all of our accounts. And just being aware of the overall cloud security posture. When we talk about cloud security, when a login gets compromised, when a credential is known, that's just dangerous, particularly for large corporations. And I would argue that the most danger is in like governmental institutions, things of that nature, because then you were getting into like tax dollars and stuff like that that's being exploited for cryptocurrency, of all things. So it's just important to be aware of that. And then just kind of protecting the workloads and improve the control of what we're doing with cloud access. So if you want to kind of go look at this is from Microsoft. It's just their security blog. It's actually a really good article. So just cryptojacking in general. So thank you for getting through my PowerPoint with me. If you have any questions, send me a little email or chat on Canvas. I'd be happy to kind of go over stuff with anyone. Thanks again. Looking forward to the rest of our course together. Thanks. Bye.